is up everyone, and welcome to our tutorial series on an intro to Flutter. My name is Nimish and I'll be guiding you through the next tutorials in which we'll be learning all about Google's newest cross-platform development solution. For starters, what is Flutter? Flutter is simply an SDK or a software development kit that allows for cross-platform mobile app development. So what does that mean exactly? We can think about Flutter as being a framework that allows developers to design and build for Android and iOS simultaneously. Now this is fantastic because if you're a mobile app developer that wants an app for Android and iOS platforms, you kind of have to build two apps in one. There are some platforms that allow you to do both at the same time, but from personal experience, I found they're not very good. This is where Flutter kind of comes in to save the day, as we only ever need to build one app rather than one for each platform. Flutter is also used to create apps using Google's Fuchsia platform, although we won't be covering that in this tutorial series. And it also uses Google's language, which is Dart. Then Dart itself is a fantastically easy and intuitive language to learn as well. So why use Flutter? Why bother learning this new system? Well, Flutter allows developers to build one app only for both iOS and Android rather than one for iOS and then one for Android. This is amazing again because it allows us just to build one single app for both rather than having to build two apps. So essentially it cuts down the development time by half. It also integrates seamlessly with a variety of IDEs such as IntelliJ, Android Studio, and Visual Studio Code. Also, for those of you who like just using the terminal and a text editor, there's tools for that too. Flutter also allows for easy and fast construction of beautiful and modern UIs. Having developed for both Android and iOS, I can say that Flutter has made building up a UI even faster and simpler than either of those two platforms. As well, like I said, the Dart programming language is a fantastic one to learn. It's really easy to learn for those of you, even if you're new to coding, and it's very intuitive to use. Now, how does Flutter work overall to build both kinds of apps at once? Well, Flutter basically provides tools and simple functionality that allow us to build UIs very easily and also implement some basic functionality using Dart and the widget system. It's actually very flexible and has almost all the tools we need. We start by developing pages with the basic functionality for both iOS and Android, again with the same code. This is great because we don't need to write the Java code or Kotlin for Android, and then the Objective-C or Swift for iOS. We can do both at the same time just using Dart. However, this does mean that there is some platform-specific functionality that's implemented in the corresponding iOS or Android files. The big problem here is that Apple's hardware is very different from Android's hardware, and so there's specific communication between the Android hardware and, let's say, Java code, and the iOS hardware and, say, Swift code that does need to be implemented in those respective platforms. However, that's only for a small subset of tasks, and the vast majority of tasks can be accomplished just using Dart and Flutter. So, who should then be using Flutter? I often see this question scattered across various chat forums. Should I learn Flutter, or should I stick with Android or iOS? Well, anyone who wishes to quickly and easily develop the same app for both Android and iOS should be learning Flutter. It's totally worth it to take the time to learn how to use Flutter to create these apps, as, like I said, it cuts down on development time almost by half. That way you can develop just a single app for both platforms rather than one app for each of them. Now, that being said, if you are developing specifically for just one platform, maybe you really like iOS or you really like Android and don't really care about the other platform, and especially if you're very familiar with a specific one, so maybe you've been an Android developer for years and really don't care about iOS, it's probably best to stick with that specific platform. So, bottom line is, if you want to develop for Android and iOS both, then do Flutter. And if you just want to stick with one specific platform development, then go with that, either Android or iOS. So, last but not least, what are some special Flutter features that make Flutter so great? Well, there's a few here. The first is that widgets. Everything UI related in Flutter is a widget, from frames to padding to gesture recognizers and buttons. Basically, almost anything UI related is considered a widget, and this is really great when writing Dart code because it means you can basically swap things in and out completely interchangeably, and it ensures that everything follows a basic and familiar pattern. There's also the hot reload feature, which allows you to almost instantly rerun your app to see some changes, at least to the UI right away. If there's state-related changes, you may need to restart the app from scratch, but this hot reload is super fast and you can see most changes pretty much right away. There's also very smooth UI changes with Flutter specifically, as Flutter uses the GPU to update the UI in, I think, 60 FPS, so changes are made seamlessly. This means that changes to the UI don't take ages to load, they're done instantly. There's also this AOT compiler, which is the ahead of time compiler. This definitely saves time at runtime because the app doesn't need to load and compile the code on the go. It basically does it beforehand. So that means the Dart code is compiled into Swift or Objective-C for iOS or Java and Kotlin for Android ahead of time rather than on the fly. Alright, so that is just about it for an intro to Flutter. Now we'll move to downloading and installing the correct software, and then of course Flutter, and then exploring some projects. So I hope you're really excited about learning to use Flutter. I love using it. I think I prefer it by far to either Android or iOS development anyway. So I have no doubt that you'll find great use for Flutter in the future. So as always, thanks for watching. We'll see you guys in the next tutorial. What's up everyone, and welcome to our tutorial on installing Android Studio. Here I'm going to show you how and where to download and install the program Android Studio, which will allow you to develop mobile apps. So why go with Android Studio versus some of the other IDEs out there? Well, I've highlighted 4 main reasons, although there are plenty of others. The first is that these other tools integrate seamlessly with Android Studio, tools including Flutter and other Google tools such as Maps or Firebase. Most of these tools actually come with Android Studio when you download it. There's no extra need for SDK downloads or anything like that. The other tools such as Flutter do require an SDK download, but the integration steps are very, very easy. This makes a lot of sense as Google's focus is mostly on the Android platform versus the iOS platform, so of course they'd make their tools as readily available as possible. The second reason is that, in my opinion, it's the best system for Android-specific development. There are a couple of other IDEs out there that you can use to build Android apps. I personally have just found that Android Studio is set up for Android app development in particular, and so contains the widest suite of tools and makes them the most readily available. I mean, the name of the program is Android Studio, not iOS Studio. So, the third reason now is that Android Studio can be used on a Mac, PC, or Linux with relative ease, and the best part is that it's free. So this means that you don't have to have a specific system to download and use Android Studio, nor do you need to pay any membership fee or anything like that. This is different from some of the other systems such as Xcode for iOS development, which requires users to have a Mac. The fourth reason I highlighted here is that I found that Android Studio is more user-friendly than text editor and terminal, and this is almost an objective fact. I've had my fair share of time using text editor and terminal, and I'm sure there are those of you out there who swear by that system. That's totally fine. It's just I've found that Android Studio contains a bunch of tools that help you to develop much more easily than just using the text editor and terminal. And the fifth and final unofficial reason is that I personally have had the most experience with Android Studio. I've been using it for many years now, and I found it to be basically everything I could ever need in terms of an app development platform for Android apps. So what are the steps going to be in this tutorial? It's not just going to be slides. Here we're going to download the Android Studio folder, then we'll install Android Studio. That will actually get the program into our system, and then I'll show you how to access the Flutter and Dart plugins if you already have the Flutter SDK. If you don't have the Flutter SDK, don't worry about it. We will install it in the next section if that's what you're interested in. If you don't care about Flutter at all, then completely disregard that last bit. So let's head on over to a browser now. I've got Chrome open here, and I'm going to search for download Android Studio. Okay, I'm using a Mac, by the way, just a heads up, so things will look a little bit different for me versus for you if you're using a PC or Linux. So we're actually going to go and click on this first link here. Download Android Studio and SDK tools. This should actually automatically detect your system. For example, for me it's for Mac, but you can go to download options and select a different one. There's Windows 64-bit, 32-bit, there's Mac and also Linux. So in this case, I'm going to go ahead and download this DMG file. Okay, we have to, of course, read this. Definitely do. I'm sure you all will. And then we're going to go ahead and check off that box and then download Android Studio for Mac. Now, if you want to check out some of the manuals for help, as in build your first app, there's, well, we don't want to do that because we'll provide better videos than that. But there's also the actual documentation on the Explore Android Studio section. So if you want to check those out, feel free to do so. Otherwise, I'm going to show you basically everything that these are going to tell you to do anyway. So it's just going to take a minute or two to finish downloading. I'm just going to pause my recording and come back once this is done. Alright, and now that we're done, we're going to either navigate to the Downloads folder or wherever you put this, or you can simply click on this guy to open. It's a folder that is zipped, I believe, or a DMG type folder. So once you open that, it's just going to go ahead and unzip that folder. So let's just wait for it to be done. Okay, and it should download this Android Studio app. If you're using a Mac, the process will be a little different. If you're doing Windows, it will direct you to the install wizard. And once that's done, for Mac users at least, all you're going to do is you're going to take this app and drop it right into applications. Now, I already have Android Studio in my applications, as you can see here. Where is Android Studio there? So I'm not going to follow that step and re-add it. But if you're using Windows, again, just follow the installation wizard. It's actually a really easy setup. And those of you who are using Mac, make sure you do that. So once that's done, what we're going to do is open up Android Studio now. And you should see this welcome window here. This time my version is 3.3. You may find a later version depending on when you're watching this tutorial. And if you don't have the Flutter SDK installed, then you probably won't have this option here, start a new Flutter project. Otherwise, you can open up a new project by doing this, open an existing one, check one out from version control, so like GitHub or Bitbucket, profile or debug the APK. You can import a project here, or you can import an Android code sample. What we're going to do really quickly is actually go up here to Preferences. Okay, we're going to go to Plugins here. And we're going to search for Flutter, okay? And it should say install here if you don't already have it, so go ahead and install that. After this, you're going to search for Dart, and you're going to do exactly the same thing. There's a chance that you might not have these repositories available, or these plugins rather available, if you do not have the Flutter SDK yet. So if that's the case, don't worry about it. We will do that in this next section coming right up, assuming of course that you do want to use Flutter. Otherwise, that is it for now. You have Android Studio downloaded and installed. The next step again is going to be to install Flutter, and then after that we can start up some projects and explore Android Studio a little bit. So, as always, thanks for watching. We'll see you in the next one. What's up everyone, and welcome to our tutorial on installing the Flutter SDK. Here I'll show you how and where to download and install the Flutter SDK. This will give you access to Flutter and Dart so that you can begin cross-platform development. So what steps are we going to do? Well, we'll first have to, of course, download the SDK. We'll then unzip it and move it to a secure location. This is a very important step. We need to know exactly where it's stored and be able to access it easily. We'll then run a command flutter doctor. What this will do is it will check all of the possible IDEs that can run Flutter, and it will list you any problems you need to fix in order to run Flutter on that IDE. I'll explain more about that when we reach that step, and the final step to this process will be, of course, to fix any of those problems that arise after running Flutter Doctor. This will allow you to integrate with your IDE of choice. So let's head on over to a browser. I've got Chrome open here, and we're just going to search for download Flutter. Okay, we're going to select the second link. This is going to be the flutter.io docs get started install. And then we'll select the respective system. So Windows, Mac OS, or Linux, whichever one you're currently working on. I'm working on a Mac, so that's the one I'll choose. And we're going to go ahead and download this zip file. Do, of course, make sure that you do have enough room. So we'll download that. Mine defaults to, I believe, my downloads folder. Make sure you know exactly where this is stored. I think my download's being a bit slow right now, so I'm just going to pause my recording until this is done. Alright, so it looks like it's finally finished downloading. We're going to go ahead and just unzip that. Should just take a second, and it's going to unzip this into a folder just called Flutter. Now that contains the SDK itself, and again we'll want to move that to a secure location. So by secure, I don't mean we have to hide it within a bunch of directories and put passwords and stuff. I just mean we need to keep it somewhere where we know exactly where it is and can access it easily. For example, for mine, this is it, by the way. This is what it looks like if you open it up. For mine, I've put mine under desktop and under Flutter. So here is my version of the SDK, which means that we can go ahead and just delete this zip file. So once you've moved your Flutter SDK to somewhere else or copied and pasted it, then we can proceed. So the next step is going to be to run that Flutter Doctor step. So what we're going to do is actually close that guy up. We're going to open up Terminal or Command Prompt for you users, Windows users. You might want to run this as an administrator, by the way. And let me just zoom in a bit. We're going to navigate to where we saved that Flutter directory. So that's why I said you want it somewhere that's easy to access. You can navigate around by using CD to change your current working directory, or LS to list everything in your current directory. For example, I might want to go to my desktop. I'm not sure what's there, so I might want to do ls to print everything out. I want to go to my Flutter directory, ls, and as you can see, I have my Flutter SDK right here. So make sure that you are in the same directory as your Flutter SDK. You don't need to go into this, just right here is fine. And we're going to have to do a command which will export the path. So we're going to set the path equal to, we'll do a $pwd /flutter/ bin $path, like so. Okay, so run that command. That will basically point to this bin and set that equal to path so that we can run Flutter Doctor like so. Okay, and this is going to run that Doctor. Now, we said I'd explain a bit about what this is doing. Essentially, what this will do is it will check all of the possible IDEs that we can use: Command Prompt, Android Studio, IntelliJ, Visual Studio Code, and Xcode. I believe those are all of them. And it's going to print out any issues that we might have, as well as print out green check marks for the good ones that are ready to use. So, for example, for some of these, on my screen, you can see the green check marks. That means those are good to go. There's no further work necessary to integrate Flutter there. However, for some of them, you'll see that there are these kind of yellowish, yellow-brown exclamation marks. And then there's even some red X's here. So the red X's are items that need to be fixed in order to use Flutter for that particular platform. For example, IntelliJ needs the Flutter and the Dart plugins installed. I'm kind of fine with leaving this alone. I personally won't be using IntelliJ. I'm only focused on Android Studio. For those of you who want the iOS development, you need to, of course, make sure Xcode is good to go. If you are using Windows, then you'll have to disregard this completely, because I don't think you can obtain Xcode for Windows unless someone has released a mod for that. So just make sure, we're going to be using Android Studio. Make sure that Android Studio is good to go. And if this is kind of giving you these red X's, I'll show you how to fix that really quickly now. So what we'll want to do is actually open up Android Studio. We'll want to go to our preferences. We want to go to plugins, okay, and we're going to search for that Flutter plugin. Now, you may have done this already, but basically just go ahead and install that. and then the same with the Dart plugin. Again, same thing, okay? And you'll probably need to restart Android Studio. Once you do, then if you run Flutter Doctor again, it should basically resolve any of those issues. So you know there are no issues under my Android Studio, but basically I do have those issues under IntelliJ. It should give you these exact same problems if you don't have those plugins installed. Okay, so go ahead and fix the issues. It usually tells you exactly what you need to do to fix the issues. If not, hunt around a little bit. Make sure that at least one of these IDEs is the Visual Studio Code, IntelliJ, Android Studio. One of those is good to go, and you can use Flutter in those. I won't really be working so much with Terminal and a text editor for Flutter development. I'll be using, again, Android Studio, so I recommend you stick with that one. Otherwise, at this point, you have Flutter installed and are ready to go. When you start Android Studio up again, you should see the option to start a new Flutter project. That's what we'll be taking a look at in the next section. Okay, so we'll get to know Android Studio with the Flutter plugin a little bit more, and then we can examine a Flutter project. Maybe we can even run one, set up a simulator and run it, and then we'll know all we need to know. We can start our actual Flutter app development. So, as always, thanks for watching. We'll see you in the next one. What's up everyone, and welcome to our tutorial on exploring Android Studio. Here we're going to explore the interface of Android Studio, specifically with the Flutter plugin, as it's a little different from the interface of the regular Android Studio. So what we're going to do here, we'll start by setting up a new Flutter project with Android Studio. We're then going to explore the interface a bit. We'll take a look at the windows, the tools, how to find what we need, and then we'll take a quick look at the project structure of a Flutter specific project. So the goal here is just to become better acquainted with the software itself, as of course we need to know what we're using before we can start using it. So let's head on over to Android Studio now. I just started up a new window. We're going to get started with a new Flutter project. I'm assuming at this point you have installed and downloaded Android Studio and have the Flutter SDK. So let's start a new one. There's just going to be a regular Flutter application. So select that. Okay, we can call this whatever we want. Flutter app is fine. It really doesn't matter too much, but what is important is this Flutter SDK path. So you remember when I said move that Flutter SDK to somewhere secure, what you'll want to do is likely browse for that. So in my case, again, I put mine under the desktop, under Flutter, and here. And basically we'll just want to select the folder itself, click open, and that's going to be the location of that SDK. So make sure that is there. I think it should tell you if it's valid or invalid. Okay, give this project a name. You'll definitely want to provide a specific location for this project. So for mine, I'm just going to do users/owl/desktop, and this should create a new folder called Flutter app, and it will place everything within that. We can also provide a description, although that's not necessary at this stage. Okay, we'll click next, provide a domain. I'd recommend you put something here, even if it isn't a valid company domain, that's fine. We'll leave these unchecked, and then we'll go ahead and select Finish. So this will actually create our Flutter project. Interestingly enough, it creates the Android and the iOS portions as well as the Flutter portions. The Flutter specific portions that just contains all of the Dart files is actually the easiest to work with. Okay, we should see that loading up in just a bit. In fact, it might take a few seconds to run the Gradle script and fully finish indexing and everything, so I'm just going to pause my recording until that finishes. Alright, so it's fully finished loading. We're actually not going to explore the files specifically too much. Let's get to know our interface a little better. So I'm just going to close that guy up. And same with the event log. Okay, so for starters, you'll notice up top I kind of auto hide my bar, which is why you may or may not see these. I have various different menus. So files, just file specific stuff, you know, your classic open, new, project, save, etc. Okay, we can also change things about the project structure itself. If you want to change stuff about Android Studio, this is more specific to the IDE itself, as opposed to any specific project or anything like that. You can find these under here. Again, preferences, that's where we installed the plugins. The edit menu just has basic text editing stuff. You get your classic copy, paste, delete, etc. We can kind of edit the code a little bit from here. Most of the code editing is actually done under the code menu though. View just changes how the overall IDE looks. We can add or remove tools from our toolbar. For the most part, I leave this alone, although this allows you to customize Android Studio a little bit more. Navigate helps you find various items within the code. So for example, we can find declarations or implementations, we can find various classes, etc. This just helps us to navigate around the project itself. Like I said, code is just used to kind of modify the code a little bit. It's kind of like an edit, but specifically for code. Analyzing just helps you to make your project a bit more efficient. For example, it provides inspections, code cleanups, etc. And you can analyze dependencies. It just provides a way to kind of acts a bit like a spell check but for your code. Refactor allows you to change multiple things in a project at once. For example, let's say you wanted to change a file name. Very often you'd actually have to perform a full refactor rather than just renaming the file. And that's because there might be various usages throughout the code that rely on that previous file name. Build has to do with actually compiling, or what's called building the code. Run provides you all the run and debug options here. Tools just has various other tools. For example, like I said earlier, there's Firebase. You can integrate Kotlin or the Groovy tools. There's the AVD and the SDK manager. These will be important as well. VCS is just version control, so like Bitbucket, GitHub, etc. And finally, there's the window. This just helps to modify the overall window of Android Studio. And then there's help up here. Okay, so what I'm more interested in is our tools on the toolbar. This is your classic open, save, and refresh. We can go back or forwards. This is just the current working simulator or emulator. I believe I have one currently working right now. Okay, we're not going to worry about macros very much for now. We can choose which file we're running. Generally speaking, we'll run main.dart in these Flutter projects, but that may change as needed. That's our classic run and debug. This just opens up our profile. We can open up there's the AVD manager here and the SDK manager right there. Okay, this line I should mention, this tells you which file you're currently in as well as the general path to that specific file. So if I open up something else, you'll see that this is changing. If I open up my library, main.dart, you can see that that's changing up there. Now, as far as the big windows go, this window on the left is your Project Explorer. This will show you all of your files. You can change the configuration of the files by selecting one of these. Generally, I keep it on Project. I find that is the most easy to understand one. You can open up various build variants. We won't really talk about that too much, or layout captures. The structure just provides a bit of structure of the project, which is kind of cool. This tells you a bit more about the file that's currently open. For example, this tells me that in this file I have a main function. I have 3 classes here, and it tells me some methods and fields within those. And favorites just allows us to add breakpoints and bookmarks throughout the code and see those right there. So usually I just have the project window open. As needed, we'll open these up. You can just open and close them by pressing on the buttons here. Now the windows at the bottom, these actually open up when our project starts running. We're not going to worry about the printout right now. There's a logcat used to print stuff to the screen here. The to-do will highlight any to-dos in our code, so we can actually put in a to-do by doing something like this, and it will create a new to-do. We can open up the terminal here, so we can use the terminal just like we would any other terminal command prompt. And then Dart analysis will show us any errors within the Dart code itself. The event log just tells us any errors in the overall project running here. And then Flutter performance, we can examine how well the app is performing. Device File Explorer on the other side shows us the currently working device. In this case, I have this emulator up and running, and it shows us the actual File Explorer for that. Okay, and Flutter Outline and Inspector we won't really focus on too much, but Flutter Outline, kind of similar thing to our structure, but just a bit more comprehensive. Okay, note this big window up here. You can adjust the size of these, by the way. This is the currently open file. So in this case, I just have main.dart open if I want to open up others. So for example, I could open up packages, metadata. You can see that they appear here. and I can switch between them or just close them up. Okay, main.dart is going to be the one that we're working in most, and you'll see it's a .dart file. So Dart is the extension of the files that we're going to be using for Flutter development. Okay, so what else do we need here? By the way, if we close it up, we can just kind of open it again here. I guess we'll just finish up here by talking about the project structure a little bit. So for the most part, we're going to be working in just the two files, main.dart, unless we create any other Dart files, and also our pubspec.yaml file. So this just kind of allows us to add dependencies to our project. If we need to, for example, add assets, we can do so here. If we want to import stuff like fonts or images, anything else that we might need to add to the project, we have to specify that in our pubspec.yaml file. We can provide information about the project through our README file, though generally speaking we don't do a whole lot. If we need to implement Android or iOS specific code, we can open up the folders here, and they actually just provide the Android style of file structure. Okay, so for example, if you're familiar at all with Android, you'll see that most of you get the main activity, you get your resource for the layout files, and same with iOS. We can just open up the project or the workspace respectively there. What we're most interested in is our library folder. This is going to contain all of our Dart files. So even if you want to put in subdirectories, then you'll generally put them in our library file here, well, our library folder. And then all of the Dart specific files go in there. This is where we can write tests and store them. And yeah, that's just about it. So you have, at this point, a pretty good feel for how Android Studio is structured. If you have used Android Studio to develop just Android apps in the past, you'll note that there are a few distinct differences. For example, all this Flutter stuff wouldn't have been there before. These new tools up top are definitely different. There's a couple of other differences. Obviously, the project structure will be a bit different as well. But now that you know kind of where to find stuff in Android Studio, what I would encourage you to do before moving to the next section is get your IDE set up how you want it. Try to recognize some tools that you might want to add to your toolbar here. If you want different color schemes, you can do that through preferences. Same with stuff like fonts, etc. You can move windows around a little bit, just kind of customize your appearance. Once you're comfortable moving forwards, then we can take a look at how to actually set up a simulator or an emulator and run the project. So, as always, thanks for watching. We'll see you in the next one. What's up everyone, and welcome to our tutorial on running your first Flutter app. Here we're going to get set up with an emulator, and then we're going to run our very first app with Flutter, just so that we can become familiar with the process. So we'll start by creating a new AVD or Android virtual device. This is often referred to as an emulator, and if you're doing iOS specific stuff, it's called a simulator. We'll be able to customize this AVD a bit by choosing which kind of skin that we want, how much memory we want to apply. There's a lot of different customizations we can provide, but we'll probably choose some very basic default settings. After this, we'll run the app, and that will also allow us to showcase the hot reload feature. Hot reloading is one of Flutter's main selling points. The app that we'll run is just going to be that default app that comes with the Flutter project template. Every time you start a new Flutter project, there's a very basic app set in it already, so we're just going to go ahead and run that. So let's head on over to a new project now. This is actually the same app that we created when we were exploring the Android Studio from a Flutter perspective. I haven't made any modifications to the code. This again is loaded in every new Flutter project you start. So it has a blue color scheme here. It has a title of just Flutter demo homepage. And I believe it just has a button in the lower right corner of the screen. You can press that button and it keeps track of basically how many times you've pressed the button and displays it in some text in the middle of the screen. So nothing terribly exciting, but enough functionality to get you started. Before we can run this guy, we of course need to set up our AVD. So let's go to the AVD manager, which you can find up here, or under tools, and it should be the first one. Okay, so I've got a few devices set up. The ones that are ready for me to run are going to be these four with the green run buttons beside them. But I'll walk you through the process of creating one, because likely if this is your first time, you don't actually have one available. So we'll create a new virtual device at the bottom there, And I would recommend, if this is your very first time creating one, just pick one of these devices here. I think the Pixels are quite new. In fact, there's even the Pixel 2s available. Those are very new. There's some Nexus devices as well. We're just going to stick with Android for now, by the way, rather than the iOS devices, just so that you Windows and Linux users can join in as well. So I'd recommend you just stick with one of these guys for now. If at some point later on you want to customize this and bring in a different device, for example, it doesn't come loaded with any of these Samsung devices. That is something I've had to import in the past because I used to have a Samsung. You can actually find skins readily available online and download them. Then if you create a new hardware profile from scratch, you can actually select which kind of skin you want. So then you just go to your file system and find where you saved that skin there. This also allows you a bit more customization over whether you want portrait or landscape supported, what kind of cameras you want, and what kind of sensors you want as well. However, we're going to keep things simple. So let's just select one of these guys. I'm just going to go with the Pixel XL, and we'll go ahead and click Next. We'll select the API level we want to run. A higher API level will give us access to more functionality because it will give us the newest features, but the lower API levels will allow more devices and more apps to run on it. The problem is if we select a really high API level, it might actually count out some of the lower API level apps that have been created because some of them just don't really run on the new software. So I like to kind of compromise and go with a moderate API level of maybe 27. I actually don't even have 28 downloaded. I should probably get on that. But let's just select one that we have downloaded. If we don't have any, then go ahead and just download one of these APIs. So once that's all done, we'll select it, click Next. We can give this guy a specific name. I'm honestly fine with leaving it as is. We'll probably do portrait startup for the automatic orientation. You'll want automatic graphics here. We'll want to enable device frame, and if you really are feeling bold, you can go to show advanced settings and you can customize this a bit more. If this is your very first one, I'd recommend you leave it alone. But as you can see, we can add extra memory, we can add extra RAM, internal storage, we can kind of simulate an SD card, choose a different skin there if we want, enable keyboard input, add multiple CPUs, etc. But like I said, if this is your very first time, probably leave it alone. So once that's done, we'll go ahead and click Finish. This is going to create our device for us, and then once that's done, we can go ahead and start it up. We'll start running the device itself, and the device itself is just a virtual simulator of, in this case, a phone. So it will look and behave very similar to an actual phone. I think it's usually a little bit slower. So let's actually get that started up right away. We'll just select it and press this green Run button. Okay, so slow if it's the very first time, but as you can see, it looks very much like an actual phone and behaves very much like an actual phone. There are some features in a regular phone that are not actually available to a virtual device. For example, you can't actually access the camera on this virtual device. I think there's a little bit like some of the audio systems don't work. There's some features that require extra hardware that are only available in the device itself. So at some point in time, if you're testing your apps, you'll probably want to test on real devices as well as these virtual devices. It's not good to just stick with these emulators. As well, if you are testing apps to be released to the App Store, you'll probably want to test on a variety of different devices, different skins, and different sizes, more importantly. So this is, I believe it was like 10, actually I can't even remember the dimensions, it's like 1440 by almost 2000 or just over 2000. But a lot of the other devices may be much smaller, which means your apps might be squashed or distorted in some way. It's always a good idea to test on multiple different screen sizes so that you can see how your app looks on a really big screen versus a really small screen. Okay, so as you can see, it looks very much like a phone. We can open it up, take a look at any apps that are within this phone already. I think I just started this one up, so there shouldn't be anything too crazy there. You can kind of scroll left or right. You can open up Chrome. In fact, that's kind of cool. You can do Google searches and everything here, just like you would a regular phone. But that's not what we're interested in for now. We can close it up. What we really want to do is get this app up and running. So you see this little window here. You'll want to actually select an emulator or a simulator of some kind. In this case, we just have the one that's running. So we'll select that. We'll run main.dart, and let's just click this green Run button. If this doesn't appear here, you can go to your Run window or menu, and then select the Run there. And now, if this is the very first time you're running this app on this device, it is definitely going to take a couple of minutes. So I'm just going to pause my recording and come back once this is done. Alright, and it has finished loading. It took just a couple of minutes, but the app is up and running now in our device, which is kind of cool. We can kind of exit out of that if we want, and then we can load it back up again by opening any previously opened apps. Okay, cool. So this is how it works. Well, this particular app, you can just kind of press this. It changes the number of times it's been run. If you want to see the hot reload, you can do a Command S, actually hot reloads it. Otherwise, you can actually just press, I think that might rerun it. For the hot reload, you'll probably just want to do this guy here. Let's just quickly demonstrate that. So you see up here, Flutter demo homepage. Let's just say Flutter homepage. Okay, so if we do a hot reload, just did a hot reload there, we should see the changes saved. Okay, and we can see right away that the changes occur there. So that's one of the really cool features about Flutter that isn't necessarily available in the regular Android. Because in order to see any changes in the older system, you have to rerun the entire app, which is kind of a slow process. Alright, so otherwise that is pretty much it. We're not going to go through the debugger or anything in this particular tutorial. We might do that at a later date. But now you know how to build and run your apps. Just a heads up, if there is anything wrong with the app immediately, like anything that, any errors that come up at compile time, it won't run the app. It will point out the errors and it won't allow you to actually run anything. Okay, so you'll have to fix any errors before you can actually run the app. In this case, there are obviously no errors, so everything is just fine and dandy. Okay, so that being said, we can stop running this by clicking on this. If you want to close the app on the emulator, you can go ahead and just kind of clear all. And at this point in time, actually, that app will have been loaded into this phone somewhere. So this was called, I think, just Flutter app. As you can see, you can kind of start that up. And it exists just like any other app. Okay, so that's all we want to cover here. You now have an emulator set up. You can run and stop running your apps, and you're good to go. So in the next section, we're going to explore this project in greater detail, or this particular file in greater detail, and we'll match each component up to the actual app itself in the device here. Okay, just so we can get a feel for how Flutter projects are built and what we can expect from each component. So, as always, thanks for watching. We'll see you guys in the next one. What's up everyone, welcome to our tutorial on exploring a Flutter app. Here we're going to explore how Flutter apps actually work by examining some real Dart code. This will all be in main.dart because we'll be loading up that default project that comes loaded with new Flutter projects. So we'll start by opening up main.dart, we'll run the app if we haven't already got it running, and then we'll compare the app interface and the functionality to the code that's written. So let's head on over to our project now. And again, this is what the app looks like. This is the same one as last time. You know that this is no longer Flutter demo homepage, this is just Flutter homepage. It's got this nice blue bar, it's got the text up here, we've got two texts here, and we've got the button down here. So there's not a ton going on right now. We know that if we press this a few times, then this number changes here. So with main.dart open, let's start at the top and work our way down, kind of getting a feel for how apps are run in Flutter, the overall flow of things, and then of course what parts of the code correspond with what parts of this page. So, for starters, you'll see this import up top. This import, actually this is kind of small, maybe I'll zoom in for you guys. We'll go to editor, we'll go to font. Let's make this size 20. Okay, there we go. So it's much more readable for you guys, hopefully. So, Material Dart gives us access to all of the UI components. The next item is this main function, which is going to run this MyApp class. So this creates an instance of MyApp, and then we're just going to run it. Main you may be very familiar with if you're coming from other languages such as Python or C or C++. A main function is going to be the very first function that runs, and it kind of triggers everything else. You'll note this MyApp class is declared down below, so this is just an instance of that. Dart is an object-oriented language, so you'll see a lot of classes and objects. So this is extending what's called a stateless widget. So the app itself doesn't maintain state. That means the app itself isn't really going to change during runtime. There will be various other components that do change, and they do need to keep track of their state. The concept of state in Flutter is really important. Anything that will change over time needs to keep track of its state, whereas those that won't change over time don't. Okay, so this overall app isn't really going to change. My home page is, on the other hand, because remember, this number is changing here, which is a product of the page itself, not the overall app. So, by the way, actually, I should say that there's a bunch of comments that come preloaded. I didn't write these comments. It's probably a good idea to pause this recording here and give these comments a read through. So, let's talk about this build function right here within my app. So every time these classes that extend stateless or stateful widgets are created, it calls upon this build function, which actually returns a widget. That is why we're returning a material app, and then we're specifying some of the properties in here. So this build function is basically going to be used to create it and lay everything out, and then it's going to be rendering everything to our screen. So we have a title of Flutter Demo. We actually don't see that appearing in here. That's just for our references. We have some theme data, which specifies what kind of color scheme we'll be using throughout the app. It's very common to use a single color scheme in most of the places in the app. In this case, we've got this nice light blue color scheme, which we have specified down here, colors.blue. Note how this is blue and this is blue, they're the same. In fact, if we were to change this to maybe green and do a hot reload, you should see that this is going to be green and this is going to change to green as well. Look at that, okay? So pretty cool. It's just a way to kind of maintain that nice constant color throughout. So we'll just, guess that's not going to want to disappear there. All right. So after this, we have a home page. This is going to be kind of like the home class. This will be used to manage the actual page's appearance and functionality. In this case, it's an instance of my home page, which is passing in this string title here. So my home page is a stateful widget rather than a stateless widget. That means that it has to keep track of its state, and it does so by creating a state object. Okay, so my homepage state actually extends the state of my homepage. We'll explore that in just a second. Every time you create a stateful widget, you do need a state to go along with it though. So this just has a constructor which sets the title, final string title, and then we have this override function create state, which is going to return an instance of my homepage state. So this is a very basic setup for a stateful widget. You generally have some kind of a constructor. You could use a default if you don't need to set anything else up. And then you have a create state function here. So this my homepage state is where most of the functionality happens. Is there any way to get rid of this? This is kind of annoying. I guess not. I guess that's here to stay. Okay, so my homepage state is going to extend the state of my homepage. Again, this is a pretty typical declaration. You can see that we have just the one field up top, which is an int counter. We have this method increment counter, and then we have again another override to this build method. After this, we don't have anything else. Everything else is done within the build method. So this counter is simply an integer, starts at 0. As you can see, the increment counter is calling set state, which is increasing counter by 1. So this is fairly straightforward. We're literally just adding 1 to our counter variable and then calling upon set state. Every time set state is called, it will recall our build function. So basically, anytime we want to make some changes to the appearance of the page, maybe we want to change some text, or we want to change a color or something during the code's execution, then we need to call upon set state. In this case, by increasing counter by 1, we're actually changing what's going to be displayed on screen, and that's why we're wrapping it in set state. Okay, so if it's just basic arithmetic that isn't changing what's displayed on screen, we don't need to call set state, otherwise we do. So coming back to our build function, again, this is going to be used to lay everything out. You can see that we're returning a scaffold rather than a material app. Okay, so again, my home page is going to be the overall kind of page and app controller, whereas, or rather, my app is going to be the overall app controller, whereas my home page is just managing a single page here. So we're returning a scaffold here. We have an app bar that is going to be this guy up top here. As you can see, it has the title with this widget.title, which is just going to be the text there. So that's going to be this text that corresponds up here. If we don't want the app bar, we can just get rid of that. If we want to pass in a different title, for example, we want to pass in, I don't know, this garbage string here, then we should see that being appearing and replacing our my homepage state. So I'd rather have that for sure than that garbage text there. So the actual body is going to be the bulk of the page, and is basically going to be everything in here. It starts up with a center widget. This just helps to lay out all of its children, well, specifically its child, with a center layout. So it just centers everything on the screen. So its child is a column. Columns are good for stacking things one on top of the other, which is great for this because we have one thing here and the next it's on top of the next item. So columns just stack top to bottom. This main axis alignment.center is a property that is basically centering everything, in this case, vertically. And then this column has a list of children, which are a bunch of widgets. In this case, this is just going to be the two text widgets. One is a static text, you've pushed the button this many times. Okay, that's never going to change. And the other is a text which has a counter here. So that's that same counter variable from above. Okay, as you can see, it is being displayed here and it is changing every time we press the button. So that's why we have to call upon setState, because this counter variable is going to be changing and is then going to have to be re-laid out here. Okay, last but not least, we have our floating action button down at the bottom. Now actually, if we use a center widget, and I think some of the other widgets, or maybe that's outside of, I think that's actually just in the scaffold there, there is an option to add a floating action button. We can specify exactly where we want to put this, but generally speaking, it's on the bottom right corner. It's just styled up a bit, and it's nice that it kind of overlays on top of everything else. So it has an onPressed function. This is similar to like an onClick, or basically is triggered whenever you actually press the button. As you can see, it has an icon, icons.add, right here. Okay, so every time it's pressed, it's calling on increment counter. Increment counters this function up here. It's setting the state and increasing counter by 1, and then that's going to, calling upon setState is going to call upon our build function again, which is going to lay everything out again with the new value of counter in this text. Okay, so as a quick overview, that is what's going on this page. There are a few key takeaways here. The first is that my app is stateless. It doesn't need to keep track of state. It's just going to be a way to kind of trigger the execution of the rest of the page, the rest of the app. Each of our screens in an app will generally correspond with a different Dart file and will be likely stateful widgets. Stateful widgets allow us to change things on screen and then update the display, and all stateful widgets need to have a state as well. The state is where most of the actual functionality goes, and the build function is going to be used to lay out our page. Anytime we want to relay out the page, anytime we want to basically update the UI, we have to call upon setState. Otherwise, that is pretty much all we wanted to cover here. Just wanted to get you kind of familiar with matching different parts of the code to different parts of this particular screen and how we would actually go about constructing apps in Flutter. So at this point, we have just about finished with our intro to Flutter. There may be some other sections, but you know enough to actually get started with app development. I would highly recommend you check out our Dart language basics tutorial series. That will get you up to speed with some of this Dart syntax. It's fairly straightforward, especially if you are familiar with other programming languages already. But it certainly has its own subtle nuances that would be good to learn before starting app development. If you're feeling really bold or you know Dart already, then feel free to skip right ahead to our widgets tutorials or our actual intro to app development where we build a few apps together. Okay, otherwise, thanks for watching, and of course, we'll see you in the next one. What is up everyone, and welcome to our tutorial series on the Dart language basics. Here we're going to spend about an hour or two and learn all about the programming language Dart. So our goal with these tutorials is to teach you the basics of Dart. What we're trying to do is get you up to speed with how to use the language as quickly as possible so that you can get out the door and start developing apps right away. After all, developing apps is the fun part rather than spending hours just studying the language itself. This means that we'll have to focus on just the important points and skim off some of that material that's not quite as important, rather than diving super deep into each of our topics. We're essentially condensing about 5 or so hours of material into just 1 or 2 hours of tutorials, so it will be fairly dense, but we've tried to make it as easy for you as possible. Now, who are these tutorials for? Basically, anyone who is new to the programming language Dart, this is a great place to start. This is especially geared towards anyone who is new to programming in general, or simply wants to brush up on their skills, as all of our tutorials will be approached from a beginner's perspective. We do, however, expect that you have watched our Intro to Flutter tutorials and know how to start and run a Flutter project, or at the very least have some experience with developing apps through Flutter. Now, what topics will we be covering throughout these tutorials? We'll cover 5 basic topics, starting with variables and operations. Then we'll move to lists and maps, then control flow. Next is functions, and finally we'll move to objects and classes. Now, just a little about Dart before we get started. Dart is an object-oriented, general-purpose programming language. So if you're used to object-oriented languages such as Swift or Java, then transitioning to Dart will be a breeze for you guys. Dart is used for web, server, desktop, and mobile applications, so it has a wide variety of applications. The Dart language itself was developed by Google. I think it was released in about 2011, and is the primary language used on their Fuchsia platform. I don't think the Fuchsia platform has been released yet. Depends a little on when you're watching these tutorials. So why go with Dart as opposed to, say, Java or Swift? Well, Dart itself is very easy to understand and to use with clear and concise syntax. That means even those of you who are completely new to programming can pick up this language and understand it very, very quickly and easily. The language itself is extremely flexible with a wide variety of applications. As we've seen, it can be used from web to desktop to mobile. It's very easy to create mobile apps, in particular with Flutter, and Dart is a primary language used on that platform too. So let's talk about how these tutorials will work throughout the duration of this tutorial series. Well, first we'll talk about each of the topics and we'll cover some theory and maybe go over a couple of examples. I've prepared some slides for you, but there may be accompanying animations as well. We'll then turn to Android Studio, or whichever platform you choose to run Flutter on, and we'll run some code demos to demonstrate the concepts that we talked about in the slides. Now, it's highly encouraged that you follow along and actually write your own code as we're writing it, and then perhaps go on to write some more of your own examples. This will really help you become familiar with writing Dart code. I think the best way to learn how to code in any language is to try to write the code and run it yourself. That way you really get a feel for what you can and can't do with a particular language and can understand the syntax a little better. Okay, so that's it for our intro. We're going to move to the very first topic, which will be variables. Again, we'll start with the slides and the concepts, and then we'll move to the demos. So, thanks for watching and for signing up for this. I hope you really enjoy it and can learn a lot about the Dart language. It's a fantastic language. I love using it. I hope you guys will too. So, we'll see you in the next one. What's up everyone, welcome to the first tutorial in our Dart language series. This will be an intro to variables. We'll learn about what they are and how they're used, and we'll try to approach things from a Dart specific standpoint because some of the nuances of Dart variables are different from other languages. So for starters, what are variables in general? This applies to almost all programming languages. Well, variables in our code simply act as placeholders for data. Anywhere in the code we might need to keep track of a value that might change, we'll assign it to a variable. Typically, variables have a name, type, and value associated with them. The name of the variable must be unique, so we can't have two different variables with the same name. It's usually lowercase, or actually camel case, and also should describe what that variable is holding. For example, if there's a variable to represent an age, it should be called age, or something similar. The type of a variable determines what kinds of values that variable can hold, and then the value can usually change as needs be. Sometimes we want it to not change, but we'll get into that later, and we'll discuss type a little later on as well. Now, just a Dart specific thing, the default value for all variables is actually null. This is very different from some other languages that assign other values as defaults. Now let's take a look at a really quick example here. I just have one sentence, my name is Nimish and my age is 25. Now I know that's a little bit of awkward wording there, but I did that specifically to demonstrate that we have two variables and two data values. So our two variables are name and age. These are going to be perhaps kept track of throughout the code, and we need to assign values to them. We have the two data values, Nimish and 25. And below I've just created a couple of lines of code in Dart, as well as they would appear in Dart, and we're just creating a variable called name, assigning it the value of Nimish in quotes, and then we're creating a variable called age and assigning it the value of 25. Now what we did in that previous example is actually taking two steps and combining them into one with both of those variables. That's both declaring and initializing them all at once. So generally we can either divide this into two parts, this two-step process into the two distinct steps, or we can do it all at once. The context is kind of required there, and depending on what part of the code they're being created in, we might want to do them at once or separately. So declaring is simply creating a variable and assigning a name and a type to it, whereas initializing is taking that variable we've created and assigning it a value. So when we declare something, we don't explicitly assign a value. We can let the compiler give it the default value, whereas when we initialize something, we have to have declared it at some point in our program. Okay, so let's take a look at a quick example. We'll just take the first part of that previous example, my name is Nimish. Okay, so we have a variable name and we have the value of Nimish. Well, if we break this down into declaration and initialization, for the declaration, we just get variable name. We haven't assigned a value yet, but we're just creating the variable. And then later on, the initialization is saying name is equal to Nimish. So there we're taking that variable we created and we're giving it the value of Nimish. So usually we can break it into the two steps like this, or we can do it all at once. It depends on the context a bit. Now let's talk about types specific to Dart, as some other languages have extra types. Some languages don't quite have these types, as they might be a bit more primitive. But general variable types dictate the kinds of data that a variable can represent. So you might note in those previous examples, we had one value that was in quotes, and then the other was simply a number. Well, those are actually two different types of variables. The first is a string, that's the quotes, and the second is a number, in this case a whole number, so an integer. Now Dart variables can have an explicit or an implicit type. That means we can create a variable and assign it a type when we declare it, or we can just say variable x is equal to and then some value, and in that case the compiler automatically interprets the type of the variable. However, unless we use the dynamic keyword, we'll get into that later, the type of a variable cannot change once assigned. It's very different from languages like Python, for example, where if we create a variable, we can assign it a completely different type later on. So there are four basic types of variables in Dart. There are integers, doubles, strings, and booleans. Integers represent whole digit numbers, so that means 0, -1, +1, etc. Doubles are decimal numbers. Strings are anything between either the double or the single quotes. It doesn't matter in Dart, but they're used to represent messages or names or anything that might have a text value. And booleans are simply true or false. They're the most simple of all variable types. So let's expand upon our previous example and see if we can explore one of each of those four types. so we've got a new couple of sentences here. My name is Nimish and my age is 25. We've seen that. We also have two more pieces of information. I'm a male and my height is about 1.8 meters. So we have the two variables from before, name is equal to Nimish and age is equal to 25. This time, however, note the code is different. Instead of variable name and variable age, we've actually assigned a string name and an integer age. So we're saying that variable name is of the type string, so it goes type, name, then value, and that variable age is of the type integer. So this means I couldn't take name and necessarily assign it the value of 25, just like I couldn't take age and assign it the value of Nimish in quotes. Now we also have those two other pieces of information. I'm a male and my height's about 1.8 meters. So I just created a double to represent the height. 1.8 is a decimal number, so it's not good for an integer representation. And I created a boolean, is male. I set this equal to true. There may or may not be better ways of doing this. I just wanted to demonstrate boolean values to you. The alternative value to is male would be false. So if it's not true, then it's false. That way it's just a bit more encompassing. Okay, so this is the final thing we want to talk about. We probably won't go very in-depth into our code examples. Just want to make a side note. I mentioned some variables might not be able to change. Well, we absolutely do run into place in the code where we want that. Some variables we want to keep their value and never change. So these we can declare to be final or constant. So we put those before the variable type. We'll take a quick look at those in the code. But basically, once they're declared either final or constant, their values can't change. Variables whose type should change, or rather can change, should use the dynamic keyword instead of assigning a type. So let's say I want to be able to change the type of my variable name. Perhaps age would be a bit more appropriate. So in that case, I would do, instead of integer age is equal to 25, I would do dynamic age is equal to 25. That way I could assign it a string value, or an integer value, or a boolean value, or a double value. There's also runes. That's a type that exists in Dart. These represent Unicode characters. If you're familiar with those, then it's just a way to enter a 4-digit Unicode character and then get the actual character value back. And then symbols represent something declared in a Dart program. Likely we won't really cover symbols at all, and probably won't dive into runes as I think they're a bit less relevant for the basics of the Dart language. Okay, so that's it for the theory. I know that was a lot to take in, so maybe go ahead and review those slides if this is your first time using variables ever, but we'll also solidify these concepts in the demo to come. So that's where we're going to turn to a new Flutter project. Go ahead and get a Flutter project started so that we can launch right into some code examples. All right, so thanks for watching. We'll see you guys in the demo. What's up everyone, and welcome to our Intro to Variables demo. Now that we understand a bit about the theory behind variables and how they're used, let's now turn to the code where we'll be able to write some of our own examples in real Dart code. We'll also be able to run these and print out some values. So let's turn to a new project. I've got one started I've called Explore Flutter. It's actually up and running right now. I think I cleared out most of the stuff from the main page. It looks something like this. It's just got a hello world text, but how it looks doesn't really matter too much. We'll just be printing stuff to the console, if anything, for now. So if you go to your, I think this is main.dart, if you go down to my homepage state and go down to this build function, we'll be writing the code in here. It doesn't really matter too much why we're writing the code in here. Basically, it's just going to be able to print to the console every time we go to rerun it. So we'll be writing stuff here if we want to write anything at all. So I'm just going to make the font a little bit bigger for you guys. I think it's kind of small. It's under editor, by the way. So hopefully that's a bit easier for you guys to see. All right, good stuff. So this example that I want to roll with, that will hopefully cover most of the points, is going to be the example of creating a game character. So we'll be using this theme of creating a video game character throughout the entire language basics tutorials. And I think this is a really good example to demonstrate a lot of the concepts, because many of you will hopefully go on to game development, and so you'll be able to apply some of these concepts in your real code. So a game character will have a lot of attributes, no doubt. We'll just be focusing on a few. We'll take a look at how to set up different variable types. So the first thing a video game character might have is going to be a name. I believe a string is probably the best way to represent this. Okay, I'm not going to assign a value just yet. We'll just declare these variables. We'll give this character an X position. We'll not worry about a Y position for now, and realistically you'll probably want to create a custom object later, but for now we'll just do a regular integer to represent that. It's going to be our X position. We'll have a certain speed at which a character can move left and right. This I'll actually name to be a double. So we'll do double speed. And then we can have a boolean that dictates whether or not the character can move. Perhaps there's at some points in the game where the character cannot move for whatever reason. So we'll just have a bool can move, like so. Alright, so here we've declared 4 different variables. Again, the default value for these variables is null, so they don't have any specifically good values right now. If we want to print something out, we can call upon this print function. For example, if I want to print out name and I go to refresh this, it's likely going to be printing out null, and indeed it does. Okay, it'll be the same for all of these. So in this particular scenario, there will be some values that are inherent to the character. For example, characters will probably start off with a basic speed, whether or not they can move, and a name for sure. But perhaps they're dropped at different points on our game screen, so they might not have a set X position. So what we're going to do is we'll actually initialize these right off the bat. We'll set can move equal to true because we want our character to be able to move. Note how this is dark blue. I believe if you're using the same color scheme as I am, that indicates that it's a built-in value. Let's have the speed be equal to, I don't know, 1.5, whatever that would mean, maybe 1.5 tiles or something. We'll not add this just yet, but we'll also give it a name. Okay, so we can use the single quotes like this, or we can use the double quotes. It doesn't really matter which one we use. I usually use single just because it's a tiny bit faster. So I'll give this character a name. You can really choose whatever you want. This is just a silly example, so I'm just going to call mine Nimbot. Alright, so perhaps we'll want to assign an X position later on. We can absolutely do that. What we would do, because we've already declared it, is going to be X position is equal to something, maybe 2, whatever that would mean again. What we couldn't do is then set maybe a Y position variable equal to 2 because Y position hasn't been created. We're trying to initialize something that doesn't exist, so we would have to first create it. Similarly, our X position variable is an integer that we've explicitly set up here. We could have done this variable xpos, and the compiler interprets it to be an integer after it's assigned a value, but we want to be as explicit as possible. So what I couldn't do then is say X position is equal to the string version of 2 like this. Okay, and that's actually throwing me an error because it's trying to assign a string value to an integer type variable. That's not going to be allowed unless we declare this to be dynamic. So maybe out of these 4 variables, the one that makes the most sense to be dynamic is can move. Perhaps we'll want to be able to print out true at some point as a string. So rather than a boolean, let's make this dynamic. If I can actually spell it properly, we'll make this dynamic rather than a boolean. So note no errors here. Okay, this way what I can do is do can move is equal to false. Okay, that's fine. I can also do can move is equal to maybe 2. I can do can move is equal to some string, and so on and so forth. So by calling dynamic, this allows a variable to change types at will. So I'm just going to change to false because in this case it makes the most sense. Or maybe we'll just make this a string. Okay, so what else might we want to demonstrate? Well, perhaps we want to make one of these variables or more of these variables final. So out of these 4 variables, which one makes the most sense to be final? Remember, a final variable cannot change its value. It's essentially a constant. Well, I think the name makes the most sense because once a name is assigned, we're going to assume we cannot change that character's name. We obviously want it to be able to move around. Perhaps there will be certain items that can enhance this character's speed or slow it down. And there's no point setting this to true if it's never going to change. We might as well eliminate the variable. So let's make this string name final, like so. And this way we cannot reassign it. So if I try to reassign my name to something else, it's actually not going to work. It's going to say that this is final and that it can only be set once. Now, the last thing I want to demonstrate is the concept of a constant. And this is something that I brought up briefly when I talked about final variables. Essentially, it's another way to say that a variable cannot change its value. We'll Constants, however, come with a defined meaning. Basically, a constant is supposed to be some kind of like maybe a mathematical constant. So, for example, the speed of light would be a constant, or the gravitational constant, 9.8, would be a constant as well. Whereas a final variable is just, some variable we've created that cannot change its value. So let's say in this game we're trying to employ some kind of actual physics here, some kind of realistic physics. We're going to just create a variable. Let's make this a constant. This is going to be a double. We'll call this g, okay? And this is just going to be equal to whatever the gravitational constant is. It's going to be 9.8. Then if we try to change g, that's not going to allow us to do so. Let's say we try to change it to 9.9. Again, this is going to say that this is a constant and it cannot be reassigned a value. Okay? So that is just about all we want to cover as far as an intro to variables demo goes. We're going to be taking a look at some much more interesting stuff as we'll be introducing operations and things we can actually do with these variables in the next demo. Before I leave, I just want to say a couple of things. The first is that if we are unsure of what these variable values are, we want to make sure something's working perhaps. We can run, again, our print function and we can put whatever we want in here. So we can put our name, we can print out strings, we can put, let's say, the integer, the x position, we can put in our dynamic boolean, so whether or not the character can move, so on and so forth. We can put anything in this print function and it's going to, once we refresh it, print that value out. So we should see that appearing false right there. Okay, and the final thing I want to leave you with before we end the tutorial is that you guys should try to practice some of this stuff on your own. So a game character, like I said, is going to have probably a lot of different attributes. There's a ton that goes into building and managing games. So perhaps try to think of maybe one more variable off each type. So one more string, integer, double, and a Boolean variable that would correspond to a game character. This could be generic, could be specific. Just try to come up with one of each of those 4 types and create some variables yourselves. Once you're comfortable using the basic variables, then we can move on to operations. Again, we're going to turn to the slides or the theory first, and then we'll explore the actual code with some demos. All right, so thanks for watching. We'll see you guys in the next one. What's up everyone, and welcome to our tutorial on variable operators. This is the second part of our variables lesson, and here we're going to learn some common operations we can perform on the variables that we studied previously. So which operators are we going to be covering here? Well, we'll study 5 main categories. The first is going to be arithmetic, then assignment, third is equality, the fourth ternary, and finally we'll look at logical operators. There are a couple more categories of operators available in Dart, however I find them either to be not so relevant, meaning we don't really use them too much, or we need to learn a bit more about them before we can dive into those operators. So we'll skip over those ones for now. So onto the first category, these are arithmetic operators. These are probably the most straightforward. We've probably seen most of them when we actually perform mathematical equations, which I'm sure we've all done at some point. I've divided them into 2 categories. First is binary and the second is unary. So the binary operators require a number or something on either side of the operator. And these consist of our basic addition, subtraction, multiplication, division. There's also floor division and the modulus operator. Floor division performs division and discards the remainder, whereas modulus does the same thing but returns the remainder and discards the actual result of the division. So here's just a really quick example. We've got an integer called result, and it's just the result of 5 plus 10. Okay, so those values could be variables, or they could be literal values, or they could be a mix of the two. It doesn't really matter as long as the types are the same. For example, we couldn't do 5 plus and then some string, but weirdly enough we can actually add strings together. We'll see examples of that later. So the unary arithmetic operators actually only require one number. Now either they modify that number or that variable, or they return a result that would be the modification of that variable. These are our basic plus plus and minus minus operators. So I've demonstrated a couple of different uses of these. The first is if we put it after the variable. So we've got that same variable from before called result, and we're doing result plus plus. That simply adds 1 to result, just like result minus minus would subtract 1 from result. However, if we put the plus plus or the minus minus before the variable name, that returns the result of that operation, but it doesn't actually change the initial variable. So for example, if result is now 16, and we create a new variable called minus, and we've stored the results of minus minus result in that, then result still keeps its initial value of 16, but minus is now equal to 16 minus 1, so 15. Okay, a bit easier to understand once we see examples in the code again, so we'll be covering some of these. Okay, next we'll move to the assignment operators. So we've all seen the basic single assignment at this point. We are basically using it to assign a value to a variable. And here we've just got an integer x equal to 5. We've all seen this before by now. So where it gets a bit more complex is when we move to the combined assignment and arithmetic operators. This actually is not so difficult to understand. Basically, it's short form for the variable, and then let's say we're doing plus equals, it would be the variable plus, or rather the variable equals the variable plus, and then whatever else we're adding to it. So for example, if we use that x equals to 5, if we say x plus equals 10, it's kind of like saying x equals x plus 10. So in that case, x is 5, and so it just works out to be 15. The difference is that it's now storing that new value within x, okay? The other arithmetic assignment combined operators work in exactly the same way, just with the respective other operation. Okay, the next is going to be the equality operators. So these perform some kind of a comparison between what's on the left and what's on the right of them, and then they return either true or false based on the results of that test. So we can test for equals, that's the double equal sign, not equals, there's our classic greater than and greater than or equal, and then less than and less than or equal. And here we have a really quick example. That's just a Boolean variable called result, and that's just going to be equal to 5 greater than 2. So 5 is clearly greater than 2, so that returns a true result, and we can store that in a Boolean variable. Okay, next up is the ternary operators. There's actually only one in Dart, and I think most other languages only have the one. A few of them have others. But this is basically a way to test a condition and then produce one of two results. It's a bit like an if-else statement, if you're familiar with those. If not, then just disregard that. But basically, we have an example here of is 5 greater than 2? So it's kind of like asking a question, is this true? And if it's true, we'll produce the result on the left. If it's false, then we'll produce the result on the right. So in this case, we're creating a string variable called result. We're testing to see if 5 is greater than 2. If it's true, then we'll store the value of true in that result variable. And if it's not, then we'll store the value of false in that result variable. In this case, 5 obviously is greater than 2, so we're storing true. Okay, and finally, we'll move to logical operators. This is going to come in much more handy when it comes to testing, or rather learning about if statements and their variants, because it allows us to test multiple cases within a single statement. So we'll start with the basic negating of a value. This can be used in testing purposes, or it can be used just to turn a true value to false and a false value to true. So here we have a test that's just 5 less than 2. That would produce the result of false. Obviously 5 is not less than 2. But because we're using the negating operator, this exclamation mark, then we're reversing that. And because it's false, the reverse of that is true. And so we're storing true in our Boolean here. And the other two are going to be our OR and our AND operators. Now the OR operator takes a test on either side, and it returns true if at least one of those two tests is true. The AND operator, on the other hand, requires both of the tests to be true in order to return a true result. So here we have two tests being performed, again one on either side of our AND operator this time. We've got is 5 greater than 2? Well, that's true. But 5 is not less than 3, so that's false. Because at least one of those two results is false, then we store the overall value of false in result. Alright, so that has been a really quick intro into the kinds of operators we'll be taking a look at in this demo coming right up. Obviously, I understand that it's much easier to understand how these operations work once we actually write the code and see them in action ourselves. So this next demo will probably be a little bit longer than the previous one because we want to get you as many examples of these operators in action as possible. If you're feeling brave, then feel free to try some of these out yourselves. Otherwise, I'll show you a few test cases coming right up. So thanks for watching. We'll see you guys in the next one. What's up everyone, welcome to the demo portion of our variable operators tutorial. Here we're going to put into place the 5 kinds of operators that we saw previously in some code examples. So let's head on over to a project now. I'd recommend you get a similar sort of setup started. This is definitely a tutorial you will want to follow along with on screen as well. So you'll probably want to write your own code examples and practice some of this stuff. So I have just a string, int, double, and boolean variables. I've separated things out into the categories we're going to try, and I've got my app up and running. Again, it's nothing special. I think this is what it looks like. It's just some text. We're going to be just printing stuff to the console, so it doesn't matter what it looks like. Alright, so let's start with the basic arithmetic operations. Most of these we should be familiar with, as I'm sure we've seen them before. These are your basic addition, subtraction, multiplication, and division. The two we might not be so familiar with are going to be these guys. For the most part, they're fairly straightforward. You can add numbers, subtract numbers, multiply, divide, etc. But there are some subtle differences and some extra stuff we can do. So, for starters, let's go with a simple example of adding something to our position. Maybe we'll want a final position we've moved somehow, and we're just going to say x position plus whatever we want, maybe 2 or something like this. So this is just a character moving forward 2 units and ending up at final position. So fairly straightforward. It's going to keep the value of 4 because we're adding 2 to the already existing 2. But what we couldn't do is say final position is equal to our x position plus speed. So it's not immediately clear why this isn't allowed. We're simply adding 2 numbers together. I mean, it would make sense that we can't add like a string and a double. Obviously, you'd get a weird result there. But why can't we do this? Well, the problem lies in the fact that we're trying to store the results in an integer, but we're clearly producing a decimal result because we're adding 2 and 1.5. This is actually allowed if we're storing the results in a double. So let's say we created a double, just call this final position, and we set this equal to x position plus speed. That's totally fine. That's absolutely allowed because a double can hold 3.5. An integer cannot though. It would basically cut off that 0.5 and then it's lost. Do we round up or down? Well, neither really. We want to keep that 0.5, so an integer is not appropriate. As you can see, there are some restrictions in place there. However, if we wanted to add strings together, that is something that we can do. It works a little differently. Basically, it just sticks whatever we're adding onto the end of an existing string. So let's say I wanted to add something to my name. I want to store the results in a final name. And I'm just going to set this equal to my initial name plus some new value. Maybe I want to stick 2019 onto the end of it. Well, that's totally allowed. It's now going to be Nimbot 2019 with the space. Just be aware that it doesn't automatically add that space, and that's why I put it into the string. Alright, so I'll just quickly demonstrate these other two because we might not be familiar with those operators. This performs a division and returns the remainder, or rather discards the remainder. This just returns the remainder. So we've got x position, or final position, is equal to 4 at this point, 2 plus 2. Let's say we're dividing it by 3. So we could do final position divided by 3. That's going to give us a result of 1.3 repeating. That's not exactly what we want. What we want is just the 1 because we want to discard the remainder. And perhaps this would be a bit more clearer to see the differences if we had actually a different example. I'm going to add 5 to this so that we get final position equal to 7. And what we're going to do is we're going to take our final position with the floor division of, let's do 3. Okay, and then we'll do the same for the modulus 3. Just like this. Okay, so we're going to store these results. In fact, what we'll do is we'll just print them right off. It's probably easier that way. There's no need to create the actual variable to hold those values there. So we can just do something like this. And now if we actually go to run this, we should see the final position with the floor division of 3. So that's going to return us 2. Basically we've got 7 and we're dividing it by 3. That's going to produce a remainder of 1. We're discarding that remainder and just returning 2. Whereas a modulus is just returning the remainder there. If you want to print out any of these other values at any point in time, simply do print and then you can put whatever variable you want between the brackets. Doesn't have to be a variable, it could be a literal value as well. Okay, so that is it for the basic binary arithmetic operators. What about the unary ones? Well, these are perhaps more simple, but also have some subtle differences to them. We're actually only ever increasing or decreasing by 1 at a time, but depending on whether they go in front or behind the variable makes all the difference. So I'm just going to comment this stuff out. We don't need it anymore. Alright, so let's say we want to just increase x position by 1. What we could do is xpos equals xpos plus 1. Okay, nothing wrong with that. But we can do this even shorter, or we can do the same thing in a shorter way by just doing xpos plus plus. This modifies the value of x position by adding 1 to it, and now x position is storing 3. Okay, so that's a big difference between doing this and then just doing x position plus 1. Okay, so if we do xpos plus plus, then it's going to store the value. Same with xpos minus minus, then it's equal to 1 instead of 2. It just subtracts there. So the more subtle difference comes in if we do something like this. Weirdly enough, it actually still changes the value of x position, but it also returns a result. So we can store this in a variable. So let's call this one final position, and we'll set it equal to plus plus x position. Let's now do the same thing. We'll change final position equal to xpos minus minus. This time we'll put it behind, and then we'll see what the differences would be. So let's now refresh this, reload it. Basically what we're doing here is we're increasing x position by 1 and storing it to final position. Oh, I guess we should actually print these guys off. Okay, so we'll do a print before and after. Okay, and let's see what we get. So we get 3 before and 3 afterwards there. But shouldn't we see something different here? I mean, this makes sense. We're adding 1 to x position and storing it here. But here we're subtracting 1 from x position and we're storing it. So shouldn't this be 2 instead of 3? Well, that's not quite the whole picture actually. This only changes the value of x position within itself. This actually changes a value and returns the result. So this is basically adding 1 to x position, then storing it, whereas this is storing x position, then subtracting 1 from it. Alright, so that's the difference there. If you're not fully 100% comfortable with this, I would definitely recommend playing around with it for a bit. Otherwise, we've got to move on. So these next operators are going to be our assignment operators. So this one we've all seen at least several times throughout this tutorial even, and in other places as well. These operators might seem a little weird, but are actually fairly straightforward also. Basically, they're combining the arithmetic operation and the assignment all in one. So let's take our x position, it's equal to 2 right now, and we're going to do x position equals x position plus, maybe we're moving forwards 2. So we've got a result of 4. Again, there's nothing too wrong with this, but we can actually shorten this to just do x position plus equals 2 like so. So this is achieving the exact same result, but in a shorter form. The only restriction here is that x position has to already have a value. So if we created a new variable, so we'll create an int new pos equal to 2. Actually, let's not give a value to this one. And then we try to do new position plus equals 2. Well, it doesn't have an initial value. And the problem is the compiler isn't going to catch this right away. It seems like there's nothing wrong. It's when you go to actually run the program that you get the problem. Because it's essentially going to try to add 2 to the value of null, which is not a good thing to do. Okay, so we can think about these as just basically adding, subtracting, multiplying, dividing, floor division, modulus. It depends on the operator we're using. But basically performing the operation and then adding that result, storing that result back in the initial variable. So let's just do xpos there. All right, so that is it for this one. It's fairly straightforward. Okay, so how about our conditional or comparison operators? I think on the slides we call these equality operators. Well, these we know are going to return either true or false depending on the results of the test that's being performed. So let's say, for example, we want to test to see if speed is equal to 1.5. So we could do speed equals 1.5 like so. And that's actually going to return either a true or false result. So we store this in a Boolean, result equal to speed equals 1.5. So note the differences between the double equals, that's comparison, and the single equals, that is just assignment. Okay, so let's just go ahead and we'll print out result here. Okay, just to see. So the same thing goes with our not equals, greater than or equals, less than, and less than or equals. And it can be compared to just about anything. So for example, this is currently the value of our string. If we wanted to say result is now going to be equal to name equal to, I don't know, some garbage string here. If we want to print out the result now, well, we should get the result of false being printed there. So let's just rerun it just to see the differences. And the other operators work is exactly the same way. So we get true here, we get false there. That's exactly what we would expect. This is just going to test greater than or equal to, less than or equal to, and not equal. So I'll let you guys play around with those yourselves for a little bit. Let's just comment those out. We'll move on to our only ternary operator. So this one might seem complex, but it's actually really not that bad. Basically, we're performing a test and we're providing two possible outcomes. It has to choose between one of those outcomes depending on whether this test returns true or false. So let's say our x position is going to be equal to some new result depending on whether or not we can move. So what we're going to do is we're going to say x position is going to be equal to can we move, okay, like this. And then if we can move, we're going to do x position plus 2. Otherwise, we're just going to do the original x position like so. Okay, so let's try this with two cases of can move. So it's true right now. We're going to set can move equal to false, and then we'll do the exact same test. Okay, and both times we'll be printing out the x position like so. Okay, so what do you think the results are going to be? Well, here, can move is equal to true, so we choose this result over this one. For the second test, can move is false, so we cannot choose this one, therefore we go with this one. So we get 4 being printed out for both of them. That is actually what we would expect, because for the first one we increased x position to 4, but for the second one we're not changing x position, we're just choosing the original value here. Alright, so if you're not 100% sure how to use that one, again, please do play around with it a little bit. Like I said, playing around with stuff in this section is very, very important. Okay, so finally we'll move to the last category. This is going to be used to negate things, and this is going to provide additional cases to test. So the negative one is fairly straightforward. What we can do is just negate a Boolean value. So for example, we can print the result of can move, but negated like this. Okay, if we go to run this, then this is going to return false, as it's true right now, and we're just negating that. So as you can see, we get false. Similarly, if it was false and we negated it, then we would get true. Okay, so the next one that we want to cover is going to be the OR and the AND operators. So if you remember from the slides, the OR operator takes a test on either side and returns true if at least one of those is true. So if they're both true, then we're good. If at least one of them is true, then we're good, but if both of them are false, then we'll return false. Whereas the AND operator needs both the test on the left and the test on the right to be true in order to return true. So we'll just see a quick example of that. What we'll do is we'll print can move or false, okay, and then we're going to do the same can move and false. And let's see what we get here. So, the first one, actually we can just kind of get rid of that, but let's just ignore that first one. So we get true for the first and false for the second. And that's because can move is true, but this is obviously false. So we get at least one of them being true and can return true. In this case, can move as true, but false is obviously false. So in that case, we do not have both of them being true, and so we have to print out false there. Okay, so that is it for a basic intro into these operators. Like I said, there are more operations available in Dart. Most of them we're not going to really use on a day-to-day basis, but when we do need to use them, we'll definitely introduce them at that point. So as always, I very, very highly recommend that you do try some of this stuff out yourselves, especially when it comes to these more demonstrative items such as the operations. Understanding what you can and can't do is essential to building proper applications. You don't want to get stuck halfway thinking you can do something and then have the app crash because you actually can't. Okay, so once you've finished playing around with these, we'll move to the next topic, which I believe is going to be lists. So thanks very much for watching. We will see you guys there. What's up everyone, and welcome to the next topic in our Dart language basics. This will be an intro into lists. We'll learn how to set up lists of values, how to get and set items from lists, and take a quick look at some common list operations. So for starters, what are lists from a programming perspective? Lists are basically variables that can hold multiple values in one location. So all of the stuff we've seen so far, those strings, doubles, ints, and booleans, those can only ever hold one value at a time. Lists allow us to store lots of different values in a single variable, and also come with a variety of extra functions that help to either manipulate these lists or retrieve values or properties from a list. These are often referred to as arrays in other languages, and in fact many other languages provide different variations on lists, such as array lists, linked lists, basic lists, and so on and so forth. Lists in Dart are fairly simple, there's just the one type. The other thing that's close to a list is going to be a map or a dictionary. We'll study that in the next section. So here's a couple of examples of basic list setups. We can either provide a specific type of list, or we can just go with a generic variable. So the first is a list of strings. As you can see, variable grocery list we've called this, and we have some square brackets and then 3 different string values within these brackets. So this is how all lists are going to be set up, with that square bracket format, and then all of the values of the list go in that. Our list of doubles looks fairly similar. Obviously we're storing a different type, we're doing doubles instead of strings. We have 5 values here, but we've told the compiler that we're explicitly dealing with a list of type double. So if we're setting things up that way, we call upon a list, and then in the angular brackets we put the type of element we want to exist within that list. The difference between the two, or the biggest difference, is that the second one, the test scores, has to only contain doubles. It cannot contain strings or booleans. Whereas with grocery list, we can actually store strings, booleans, integers, or doubles. There's actually no floats in Dart. But basically the types that we're storing in that list are not restricted. So now let's talk about how to fetch list elements, or how to fetch an entire list. So much like a variable, we can get the entire object by calling upon its name. So in that previous example, if we wanted everything within grocery list, we simply call upon grocery list. That returns us the entire list with everything in it. But very often we'll just want to access individual elements or pieces of a list. Well, to access pieces, we actually use a function that will help us to retrieve a range of values, but we'll talk about that later. If we want to access just a single element, we can do so by its index. Indexing, much like in many other programming languages, is zero-based, so that means the very first index is 0, and the very last index is the length of the list minus 1. So here's what it might look like if we want to access just one element. We've set up a list of integers 1 through 5, and if we want the second element there, we call upon the index 1. Okay, remember indexing is zero-based, so the very first element is index 0, second element is index 1, and so we call upon the list by its name. We put the square brackets beside that name, and then within the square brackets we put the index of the element that we want, in this case index 1, and that retrieves us the number 2. Okay, so what about setting list elements? Well, it's not actually that different. We can, again, set elements by their index if we just want to do one at a time, or we can change the entire list by reassigning to a new list. So much like we would change a variable to a new value by setting the name equal to something else, we can certainly do a list is equal to a new list, and then that might have entirely new values. If we want to set only part of a list, again, we'll use a built-in function. But if we want to set just one element, we can do so by index. So here's a quick example. We've got that same list of integers, 1 through 5. This time we want to set the very first element, index 0, and we're just setting it to 5. So again, the list name, the square brackets, and the index we want. This time we're setting rather than retrieving. So this brings us to the last slide. Here's some very common list operations. This is just a very small subset of all of the possible operations you can call. There are a ton of different things we can do with functions that are built into the library. So to access any of these, we need to first create a list, then we call upon that list name, dot, and then whatever operation we want to call. So some of these operations retrieve values, some of them change values, and some of them will just kind of manipulate the list as a whole or partially in some way, shape, or form. So here's just some really common ones I find myself using on a day-to-day basis. We can get the length of a list, that's a very useful one. We can get the range, which is just going to get us a small subset of a list. We can set all, that allows us to change multiple elements within a list. We can insert elements at a specific index. We can return true or false as to whether or not a list contains a value. We can get the very first or very last element of a list by calling first or last. And then the index of operator I find particularly useful. That will return us the index of a specific element within a list if it exists. For example, we have a list 1 through 5 and we want to get the index of number 3. We just pass that in and then it would return us whatever index 3 belongs at. Alright, so that is it for the slides. I know this was a pretty short one, but once we know how to get and set elements, exploring the operations is just as easy as calling again the name, dot, and then take a look at the operation itself. So we'll stop here. When we come back, we'll be taking a look at a list demo. We'll be able to explore some of the concepts we talked about, specifically some of these interesting operations that we can see here. Alright, so thanks for watching. See you guys in the next one. What's up everyone, welcome to the demo portion of our Intro to Lists tutorial. Here we're going to take a look at an example of setting up a list, getting and setting items from lists, and then a few of the common operations. So let's head on over to our code project here. This is again just explore Flutter, the same thing as last time. I've just cleared the board, so we're starting from a clean slate. So I think I'll roll with this example of creating like a video game character, and video game characters very often have inventories of items. So within that inventory we might have a list of items themselves. These could be very simple. They might just be a list of names. They might be names and the number of the items you have, or they might be entire objects with a lot of extra properties. We're going to keep things really simple and just do a list of strings that represents our inventory. So basically we'll have an inventory of items, okay, as strings. So each of these items is just going to be the name of the item. Alright, so we can create a variable and call it inventory, and we can set it to, should be there, we can set it to an empty array like so. Now, as per usual, we want to be as explicit as possible. We know we're only going to store strings here, so let's actually make this a list of type string. Just like so. Okay, so now we can populate this with whatever values we'd like. So I'm just going to pick some generic items. Our character might have some, whoops, can't spell today. Our character might have some food. Maybe this character has some kind of a tool like a knife. And also characters often have rope. I don't know, whatever we might use that for. Okay, so that's step 1 complete. We've set up a list of items, in this case a bunch of strings. Now because we've said this is a string list, we can't put in like an integer or something. That's not going to work. If you had just left this as a generic variable, you can do that, but we'll stick with just strings for now. Alright, so how do we retrieve the list as a whole? Well, that's simple. We just call upon the variable name, in this case inventory. Okay, and then we can do whatever we want. So for example, if we want to print that guy out, we can do so. It's really nice actually that the Dart compiler knows that this print function wants to print out the entire list and show all of the values, as you can see below. Sometimes in some other languages it will just print out a list object rather than the actual values within, so it's nice that the print function is smart enough to do that. Okay, so what next? We know how to retrieve the entire list. What about retrieving individual elements within the list? Well, it's done again by their index. So let's say we wanted the last element here. What we could do is call upon our inventory. In the square brackets beside it, we put the index that we want. So in this case, we want index 2, again, because 0, 1, and 2. And so then if we were to run this, this should just print us out rope. Once again, there's no array bounds checking built in for this, so it would be a good idea to make sure that our list length is at least 3 before we call upon that index. And as you can see, we get rope there. Alright, so that's step 2 complete. We know how to get the entire list and also individual items. What about setting the entire list or setting individual items? Well, if we want to reset the list as a whole, we can absolutely do that. So let's say we want to change this list to something different. Maybe we want it to contain all of these items, but we want to also have an axe in there. And maybe we want, I don't know, we have some water. Okay, so now our inventory is actually a different list entirely. Okay, and so it should look different when we actually go to run it. So as you can see, we get an entirely different list, and this is very similar to just resetting a variable value. What we couldn't do is just reset it to something like this, okay? Because that's just an individual string value. We could, however, do something like this, and that's actually quite valid. Okay, so let's just reset that. All right, so what about setting individual elements within this list? Maybe we want to be a bit more specific about the food and we want to replace this with fruit. So what we could do is we could get our inventory. We can access the element, so that's going to be the index 0. Okay, and this time rather than just retrieving it, we're actually going to set it equal to something else. We'll do maybe fruit or something. Okay, and then if we go to rerun it, our inventory should have replaced food with fruit. And indeed it did. Okay, so that's those are our next steps complete. We know how to set up lists, get individual values or get the whole list, set individual values or set the whole list. So let's take a look at some list operations. Now, there are a ton of different operations, okay, that we can access, and we do so through the list name dot, and then this is how we get all of them. So as you can see, there's a lot. I'm not going to go through them all, or else this would take probably hours to explain exactly what's going on in each one. You can actually kind of hover over each one and get a little bit of an explanation as to what's going on. It actually tells you what input values it expects, and it also tells you the output value. You can also see the output value there. So generally, I personally break these down into 3 categories. The first is going to be retrieving elements or properties. The second is going to be setting elements or properties. And the third is going to be these closure type functions. These closure type functions basically take in some kind of a function itself, and this iterates through the entire list and does something. Okay, so in this case, this is supposed to manipulate something within the list, so it will visit each string element and it will do something. We can do like an any here. This just checks to see if each individual element satisfies some test. Every basically checks to see if every element satisfies this particular test, and as opposed to if any of them do, and so on and so forth. So there's a wide variety of functions to choose from. I'll just try to do one from each of those 3 categories, as again, it's just impractical for me to go through them all. Besides, I want to leave some of the exploration up to you guys as well. Okay, so the 3 functions in particular I want to focus on are going to be the set all, the get range, and the for each functions. So let's start with the get range function. I find this one particularly useful as it allows us to get a small part of a list. So let's say we want just the first 2 elements, but we don't want anything else. Well, we specify a start index. We want the first two, so we're going to start at the beginning. We want to end with this element included, so we don't end at index 0, 1. We end at actually at index 2. Okay, so let's change that to index 2. And then this will actually retrieve us the first two elements. So one thing to note is that we're ending at index 2, but we're not visiting index 2. Okay, so it's just going to include 0, 1, and then it's going to cut off at 2 rather than including 2. So if we want to print this guy out, like so, let's just get rid of that extra bracket. We can do that. Let's just get rid of that. And this should really just be returning us the first two elements. Oh, actually, this is fruit and knife. Note also that it's in a tuple format like this, rather than a new list. Okay, so that's a get function. What about a set function? So the reason I chose that inventory.setAll function is because it's a little bit weird, rather than if we just want to change an individual element or we want to set something else. So let's go with a setAll. Let's pass in a start index, and then we'll pass in a new array of elements to replace that index. So let's say we have fruit and knife right now, but we want to replace it with maybe fruit and bread or something like that. So we're going to start at index 0, and we're going to pass in a new array of values. We'll do fruit and bread. And that's actually going to change our inventory value itself, so we might want to print out the new inventory now. One thing to note is that this function is a little bit weird. We do get fruit and bread there, and then rope, axe, and water. So this function is a bit weird because we're actually starting at index 0, but we're replacing everything with these elements here, as long as the indices overlap. So this means that if we had just done this, we're only setting the very first element. If we'd done this, then we're setting the first and the second. We're basically overwriting those elements. If we'd set the third to something else, we would overwrite rope, and so on and so forth. Okay, so it's not just inserting elements. It's not just replacing one element with a list. It's actually replacing all of the elements that correspond with these indices as well. So I just found that one a bit weird. If you're not sure how to use it, then you might find things kind of going a bit wrong. Okay, so the final thing I want to go over is going to be one of those closure type functions. We'll do a for each. Now, in a lot of other languages, before I really explain what's going on here, in a lot of other languages, doing something like this, calling a for each function on a list, would actually change that original list. For example, if you wanted to manipulate these strings and do, I don't know, like a space and a 1 beside each and every one of them, you could use one of these for each functions to do so. However, with Dart, the original list doesn't get modified. It basically just visits each element and creates a reference to it. And so if we were to try to modify each of those elements, it actually doesn't change the original list. So that's just one important point to note. Otherwise, this takes in a function, specifically a closure type function, okay, and it will look something a bit like this. So it will visit each of the elements within the list, and it's going to put that element in some variable here, which we'll just call item. Okay, so for each of the items it visits, it's going to store them in this temporary variable item, and then it's going to do something with it. So what do we want to do? Maybe we just want to print that item off. Okay, again, we can't really manipulate it and store it back in the original list, so we'll just print them off for now. So if we were to save this and rerun it, it's going to go through our list and it will print each of the items within it. So we get fruit, bread, rope, axe, and water there. So just know that this is visiting each item. It's going to, as it visits an item, store it in this temporary variable called item, and then it's going to execute this function here. It could be printing an item, it could be saving an item to an array or something like that. In Dart, I suppose that would be a list, but basically we can do whatever we want with the item. Just note that, again, it's not changing the original list, but we can then create a new list out of those items if we want. Okay, so like I said, there is a ton of functionality stored within these lists. If you do want to check them out, again, list name dot, and then go through these. A lot of them will be retrieving values. Some of them will be just changing the list itself and not actually outputting anything. These void functions don't output anything. If they return something, then it's probably retrieving either a value or a property of the list. And actually, you can see the P's are for properties, the M's are for methods. Okay, so play around with those a little bit, have some fun with some lists. When you're ready to move on, we'll go to the second list portion in our Dart language basics. So as always, thanks for watching. We'll see you in the next one.